Good afternoon, ladies and gentlemen. I am serving as manager of the Line Private Cloud Platform Development Team. My name is Nishiwaki. So first of all, I'd like to understand how many of you are using Kubernetes, how many of you know about Kubernetes. I want to understand the audience. So who has installed Kubernetes? Please raise your hands. Who has installed Kubernetes? Okay, more than I expected. Who are using Kubernetes in production? Okay, far more than I expected. Thank you very much. So yes, currently KubeCon is ongoing in the US. Thank you very much for attending at Line conference. So it's been almost 3 years since we started to introduce private cloud at Line. For over 3 years, we have issues of the scalabilities, performance, and also we have expanded the not just putting the infrastructure onto the cloud, but we try to cover a higher layer. So we have to be prepared to see the expansion of our responsibility of private cloud. Our intention was trying to offer the high quality infrastructure on demand, but most recently it's not just limited to infrastructure, but we try to set up the environment so that developers will find it easier to develop. And that's the purpose of cloud improvement. So today, how we are going to set up the developer-friendly environment, and that's what I call as cloud native challenges. So first of all, I am a speaker today, and let me share my background. I joined Line in December 2017. For the first 6 months, I was in charge of the OpenStack IRs, network plugin development, and also the customization of the other components. And also I was in charge of the bug fixes. And then I launched the managed Kubernetes team, and I was planning and development of that team. Currently, I'm planning and developing the function as a service, and I am in charge of the OpenStack as well as managed Kubernetes teams. Prior to go into the main topic, we offer private cloud called Verda. So let me share the overview. Our private cloud Verda, we have two interfaces. One is Web API, the other is Web UI. So Web API and Web UI, through these interfaces, users can do the load balancer of virtual machine as well as bare metal server. So they can actually provision the infra resources, they can create or delete those resources. And also, not just IaaS layer resources, but using those resources, we could offer the managed middleware service as well as managed database service. So we offer the managed middleware services. So by offering that, the private cloud users are not going through the detailed setup or maybe the tuning or when it's broken how they should do it, but rather they can use a middleware. And also our focus recently is managed service or managed infrastructure. So once code is pushed to the repository, in the backend application can be deployed, or maybe on GUI for the any arbitrary events, any functions which are running on arbitrary events, we can run those events. Yeah, so parse layer is currently being served. Currently, we combine the different multiple layers services, and application developers, in accordance with the application workload, they are using these services. Looking at the scalability or scale, currently we have 35,000 VMs which are controlled in the private cloud. If you look at 35,000 VM, you may think it's far less than you thought. But for the last 12 months, out of which 20,000 VM have been created in the last 12 months. So I think the migration of the private cloud or maybe the far more usage of the private cloud can be expected. So that's why we expect the number of the resources in the private cloud is going to be bigger. I'd like to touch upon this at a later stage, but in the back scene of these numbers, since we have more servers, we start to see the issue that server resources are not fully utilized. So the efficiency of the resources is getting an issue. So infrastructure leverage, trying to improve the efficiency of the usage of the infrastructure, I think a cloud native technology will enable that as well. So, as I put as my title, what is cloud native? How do we interpret or understand cloud native? So I think I ask you, you have been Kubernetes or you have installed Kubernetes quite a lot. So I'm sure you have read through the definition of cloud native. But let me share our definition or our interpretation. Cloud native was defined by Cloud Native Computing Foundation. I think there are two elements which I think are important. The first line shows the build and run scalable application in modern dynamic environments such as public, private, and hybrid clouds. So that's the first red line part. There are two important keywords. Number one is scalable application, and the other one is a dynamic environment. So these are the two important keywords. And also, as you see in the second red line, these technologies enable loosely coupled systems that are resilient, manageable observables. And combined with robust automation, they allow engineers to make high-impact changes frequently and predictable with minimal toil. Maybe it's a little bit divergence of the context, but manageability and automation are the two keywords. So scalable application and dynamic environment, as well as the improvement of the manageability and automation. If we look into those in the extension of the cloud native, depending on the situation, it can be adapted to the environment. That is what we are trying to aim at. For instance, if the system capacity is not enough, then system is going to scale out automatically, or maybe at the time of the upgrade, it will minimize the impact. So if it fails, it will roll back automatically. So these are cloud native technologies. It can be enabled. And also, private cloud, if we are going to do it, this is something which we are trying to enable on our private cloud.
With these cloud native technologies, what do we want to solve? What is the challenge? I would like to discuss that point from two perspectives in terms of the benefits and motivation of cloud-native approaches. Number one is too obvious from the perspectives of applications engineers. The continuous deployment and development must be enabled by these approaches so that they are freed up time from infrastructure management as well as more complex operations can be focused on development. So this is something often talked about. You would swallow this very easily. But something that I would like to emphasize is the second perspective, that is, the private cloud and infrastructure engineers' perspective. You may not notice this in public cloud, but using cloud native, you can further abstract your infrastructure so that the operations for the infrastructure resources can be provided or provisioned without the communication with the application engineers. You may not know what it means, so let me try and explain using a more concrete example. Now, here is the non-cloud native environment. Virtual machines and bare metal servers are being utilized through private cloud APIs to develop applications and deliver them. And there are 4 steps in such a life cycle of service deployment. First off, you start with application development. where you would probably do after requirements, applications development, and coding. When that is completed, you have to deploy the developed application. So if you use a private cloud, through API, you provision infrastructure resources. After that, then, to the infrastructure resources, applications and scripts are deployed. And the deployed system is put under operation. And after that, if additional development is necessary, it is done. And the deliverables, if provisioned, if additional infrastructure resources are necessary. On our private cloud right now, including development environments, we use this cycle for 4,000 projects. Well, 4,000 projects does not mean 4,000 services. Some of them are private and mini projects, internal systems, and so forth. But anyway, regardless of what projects there are, this is a very basic cycle that you have to sort of turn. So as a result of that, each project provisions infrastructure resources as they like. For example, a certain project has to run multiple batch processes. So the purpose of C-run, they provision multiple servers, and only C-run setting is resident on those servers. And for any failures, the recovery script has to run in a certain environment, which requires multiple servers or workstations to execute scripts. And in other cases, for the increased load over the weekend, more than necessary servers may be provisioned. So, if projects are independent in ensuring infrastructure resources, the end result is over-provisioning of infrastructure resources. As a result of that, CPU usage of more than 60% of servers at line is less than 10%. And of course, there are other resources than CPU, like memories and disks. But just by looking at those stats on CPUs, we cannot brag about the utilization of the infrastructure. This is serious, and actually, we talked about establishing a project to specifically challenge this. However, VMware, bare metal servers for application developers to be created through APIs and applications deployed. If that type of a structure persists, it's very difficult for the infrastructure team to take the leadership, because in this model, our responsibility is to provision resources when requests come in through APIs. And after that resources, how applications are deployed and operated upon are outside of the realm of our responsibility. Therefore, even if we identify underutilized servers, in reality, it is invisible to us what applications and what scripts run on those servers. As a result, we cannot contribute to reducing that bottleneck. The only thing we could do was to ask application developers. So, what can the cloud-native systems do to address that problem? Well, our responsibility scope included only on-demand provisioning of VM and bare metal servers, but now in cloud-native, we can expand the scope of our responsibility to applications deployment and operations, which, however, cannot be completed only on the part of the private cloud. Application developers and private cloud have to find a place where we can they can or we can meet and do the best we can. So in the cloud-native systems, application developers generate servers and deploy applications. Application developers no longer has that responsibility and authorization. Otherwise, the application and scripts are written into TIP file. This is something that is called manifest in Kubernetes, and the private cloud managed orchestrator receives that list. Then the orchestrator makes a judgment as to which workload to run on which servers before deployment. Now the private cloud engineers have a view of what workload runs on what servers. So user-defined software and script in terms of the operations and execution is known to us so that we can provision necessary resources without having real-time communication with the application developers. Underutilized servers may be identified, and then the servers, the workload on that server can be moved to another server so that freeing up an entire server for different purposes. Not only from the application developers' perspective, the infrastructure team can now take the leadership in enhancing the utilization of the infrastructure resources. So the cloud native works in both ways. Now, up until now, I have talked about something very abstract. I don't want to bore you anymore. So, let's try and translate what I said and map them into the solutions. Earlier, I talked about the orchestrator, which you already use. Actually, we offer managed Kubernetes to application developers as an orchestrator. So through this Kubernetes, stateless applications can scale out and auto-heal because of this orchestrator. And another thing is managed middleware services, database as a service, as an example. Why do we offer this? Because by offering Kubernetes stateless applications can do the auto-scaling and auto-healing. Rather easy implementation. However, when it comes to stateful applications, auto-healing at the time of failure or scale-out occasions for performance, unique middleware logic may be necessary. Therefore, for those applications, instead of deploying using orchestrator, let's use the managed middleware that we manage. And another thing that we offer is function as a service. Managed Kubernetes and managed middleware have helped operations after deployment through automation. But as we develop and operate our systems, there are other operations which are not covered by this model. Therefore, automation platform is necessary for those applications, thus function as a service. This function as a service is something that is put on the Kubernetes layer as an abstraction layer. So managed Kubernetes and managed middleware and function as a services, I would like to let you know how they're implemented and what services they're offering.
So in managed Kubernetes, there are 3 missions. From the left, HA, performance, and also private cloud. Other functions of the private cloud to be tightly connected, and that's what we have to offer as a Kubernetes cluster to the private cloud users. Number 2 is in order to have the Kubernetes cluster stable operation, we have to operate Kubernetes cluster. Number 3 is even though we offer Kubernetes cluster, what kind of application is up and running on top of that? Maybe some application may not be up and running So the ones which are not on Kubernetes, how we are going to enable those applications on top of the Kubernetes. Maybe we may change Kubernetes or we may change the application. We have to think about those two approaches so that we can use more usage of the Kubernetes. Well, all the missions are still not fully completed or achieved. At this moment, the one in the circle have been achieved so far. So HA, the simple Kubernetes cluster, which consider HA, we offer that, and then we automate that operation of the Kubernetes cluster. That's been already achieved. Well, there's other backdrop why we focus on these missions. Well, prior to offering these services, some of the teams already started to use production Kubernetes. So that Kubernetes clusters can be actually coming to us so that they can alleviate their burden. So that's why we focus on this area. So let me give you the managed Kubernetes system configuration. There are three components which are comprising of the system. Far left, API server. So this API server is developed by ourselves, and this API server is the interface for the managed Kubernetes. So the cluster creation or maybe the update request or maybe the addition requests are actually handled using API. But using this API to come to the specific business logic of the cluster creation, it's not included. So the rancher, which is an open software, is utilized instead. This rancher is offering the management functionality for all the managed Kubernetes, meaning that cluster deploy and also maybe monitoring and also healing. So API and launchers will complete all the basic functions of the managed Kubernetes. After deployment of Kubernetes, we may have to deploy the additional middleware, and we have the different add-on manager. So all the deployed Kubernetes cluster, the one which have to up and run as middleware is managed. Let's say this middleware is stopped, or if this middleware is updated, this is a software which is managing all of these. So from now onward, let me give you the characteristics about the managed Kubernetes. Number one is the add-on management, which is offered by add-on manager. So I think you are using managed Kubernetes cluster, so I'm not going to the details, but Kubernetes cluster is deployed, then the components, Kubernetes server and others, we have additional middleware which we need to deploy. Log, Fluentity, or Prometheus, or monitoring, or maybe ingress controller have to be also deployed so that it can be a gateway for Kubernetes cluster. So Kubernetes add-on include quite a lot of implementation on internet. So if we are trying to use this, setting up those is one, and also if there is bug, you have to modify or fix the bugs. So that's why simple Kubernetes cluster is the first mission, but we also have another mission. So those middleware which have to be used by the users also can be managed by ourselves. So add-on manager, add-on API is offered if user, for instance, wants to collect the logs to one location, then add-on API enables log collecting add-on. So to that cluster, to collect the logs, the software which is required is going to be deployed. So that's also offered by us. Also, the fundamental of the managed Kubernetes, the Kubernetes build and operation is automated with Rancher. Rancher provides the automation function which is required for the operation for Kubernetes. So if, let's say, node is failed, then just one API call will replace the node. If cluster is fully broken, then one API call is going to restore the etcd snapshot, which we collect on regular basis. So we are trying to minimize the impact to the operation so that we allow the developers to spend more time. The other one is there are so many provisioning, so monitoring is really important. For the monitoring, there are two types of the monitoring which we offer. Number one is a simple health check offered by Rancher. On this one, it's just checking either 0 or 1, meaning that each function is functioning or not. For instance, for each cluster, Kubernetes API is functioning or not, or maybe for each Kubernetes cluster, we also deploy agent. So do we have the connection between agent and TCP? That's another. And also the status of the Kubernetes and also the status API results also are checked. The other one is, as was mentioned before, through the add-on management, we have Prometheus and Grafana, which is advanced health check. For this one, each metrics API of the middleware is collecting the internal state. So we set up the special threshold, and looking at that threshold, we try to understand if the cluster is okay or not. So this type of automation and also monitoring scheme will enable 5 developers to monitor 130 clusters and 2,000 nodes. Majority is still the users using this environment for the development environment, but in October we released in production. So I think the production cluster is going to be even increasing. So I guess this is going to even increasing in the production utilization. So this is the last slide for the managed Kubernetes. So what we have done and what we need to do is described on this slide. So far, as I said, deploy and HA and also the automation of the Kubernetes operation have been our focus. So that's why it's a simple HA cluster and also add-on features and also operation automation have been already achieved. So due to these, I think several services are already used in the production environment, but not many. So in order to really further out the application of Kubernetes, we would like to continue our development to be more specific, performance improvement is one, and also maybe we are trying to lower the hurdle for users to use Kubernetes. We are trying to have add-on functions. The next one is the currently planned functions services, which I'd like to discuss.
Up until now, I talked about managed Kubernetes. You may be wondering why we want to offer function as a service since you use Kubernetes clusters. So probably it is better to start with that one. Using Kubernetes, various operations can be automated. For example, auto healing for application failures, as well as auto scaling of applications, rolling upgrade of applications. Such operations can be easily automated. Having said so, there are other applications. As you develop and operate applications, there are many events that you encounter. For example, in monitoring systems, when you receive certain alerts, you want to have specific data, specific processing ready, and also dependent systems, dependent private cloud components may require periodic maintenance, or certain outage information has come up and you want to do certain operations. And periodically, you want to run certain batch processes. So these operations with a monitoring system through webhook APIs and using webhook servers, you can do that. Or you may build a chatbot. And there are various solutions available. However, the management cost is something that you cannot overlook, as well as development cost. Thus, Without automation, you may be doing some of this without automating them. So in order to respond to such use cases, we are developing function as a service. They come in two concepts. Number one, appropriate events at appropriate time generated by event provider. And such events are collected and consolidated so that the functions, whether the functions are linked would be checked by the function services. But in reality, for implementation, this may look like this. A lot of blocks in a single slide, so it may be difficult to get to what I mean. So probably I should talk about the details of each blocks. Now, the function service API servers and controllers. Kubernetes customer resource definition is largely leveraged in implementing this. So the API servers in front uses Kubernetes, is almost like Kubernetes APIs to find resources linked to a certain request and then store that information in Kubernetes. Controller is another component which watches that process, so that generated resources are being checked and new functions may be deployed or deleted. These APIs and controller have Knative in behind. Knative is an open source software. This software is something Google open sourced last year. It's a serverless framework. Knative itself has three components: Knative serving, Knative building, and Knative eventing. And we use all of them. In Knative building, what do we do? Actually, when user registers functions, Python program or source code is what you do. So based on that, containers have to be generated by Knative building. And after the container image is generated, Knative serving deploys the function. And Knative eventing gets the events from the external event providers to map those events to other components, and if there is any link, that link is executed by eventing. Now, the Knative serving implementation is dependent on Istio Ingress Gateway. So we do run Istio in our environment, and this is where services go through to be provided to the users. So how about event providers? Event providers, depending on the events to support, the implementations vary. So I'll take OpenStack as an example. In OpenStack, each component has resources which may change. In that case, the change information is sent to RabbitMQ. Therefore, what is being done here is Knative's eventing component consumes RabbitMQ messages, and consumed data is the basis of the linked function to be executed through Kafka. So, that's the overview of implementation of function as a service. So, what can we do with this function as a service, and what will be done going forward? One thing, what is being done is to execute simple functions. And there are three event triggers. Number one is OpenStack's resource change event. When VM is generated or deleted. So that kind of an event. Number 2 is cron or cron type of events to support periodic execution. And after the functions are deployed, HTTP can call that function with HTTP event. So these 3 triggers are being provided. But how many operations can we automate with these events? Not too many. In order to make our function services more relevant, first thing that we are working on is to enhance events to be supported. And also, functions pipelines, as well as more granular controls of functions. For example, the number of items to be concurrently controlled to be enhanced as well. So I have talked about what we think of cloud native and what problems we wanted to solve and what we are doing right now. So rather than each product's next step, what sort of vision we have in using managed Kubernetes and functions as a service going forward? Kubernetes and functions as a service would make service transparent to the users. Function service development and provisioning is done in Kubernetes. We have just started, so we have to increase the number of use cases to be covered going forward. And also, in a longer-term perspective, we want to improve the resource efficiency. That is, under the abstraction layer, we want to make sure that we have higher utilization of the resources. So this is the area that we will be switching over eventually. And this is my last slide. In order to enhance utilization of the infrastructure, what can we do? We have 2 options. Number 1 is for short-term, the other one long-term. As for the short-term option, currently, behind function as a service, we have the Kubernetes cluster. And including that, actually, we are offering various Kubernetes clusters to the users. So the first action we can take is to do the automatic scale in and scale out based on the usage base of those provisioned clusters. Even if we may offer multiple clusters, those clusters, depending on the cloud usages, will have varied utilization, and that information can be very important for us to manage the best utilization of all the clusters. But still, it takes time for both scale in and out. And also, we use virtual machines to realize that, meaning that there will be the overhead left for virtualization. In longer term, the single Kubernetes interface will have to be shown to the users. Behind it, the multiple Kubernetes clusters may work in federation, or it may be a single large Kubernetes cluster. We haven't really decided on that, but a single interface behind which we have Kubernetes running application scheduling to enhance utilization of the infrastructure. Now, the large cluster means we have challenges in isolation and scaling challenges. Thus, looking at the Kubernetes upstream communities and how they're working, we will seek ways of further improvement. With this, I'd like to conclude. Now, we're still looking for buddies who want to work with us about these topics. So if you're interested, please talk to me at the speaker session or at the networking reception later on. Thank you.